standard distribution.
There's a little bit of math, but it's nothing crazy. And mainly it focuses on experimental methods and correlation, and the fact that correlation
does not equal causation.
Okay, which is very important.
Positive correlation.
Look at causation.
When you, yes, Jake. Sexual urges. Yeah. Okay, if you guys have any questions on the study guide, feel free to ask, okay? Now's the time. Or, you can text me if you want to. Okay, so what do you call things that you either measure or manipulate? Variables, good. What is a hypothesis?
A statement that we should.
Good. Is it a question? No, it's a statement. Okay, if you're talking about sugar and hyperactivity, what would a hypothesis sound like?
Hyperactivity increases.
Sugar causes hyperactivity. That's it. Okay, sugar causes hyperactivity. Good. Did I go over inductive and deductive logic?
No.
Guys? Some classes
I
maybe?
have an empty card.
It goes from
Okay,
specific.
so inductive versus deductive logic. Deductive is you notice, okay, you know what? No, I need to go over it before it's not going to be on the final, but I will go over it before the AP test. I want to go over it so I have it right in my head because it's confusing, and I know that if I teach it to you wrong one time, it's going to mess it up forever. So let me go back to it, but it will not be on the final. Okay. What's the paragraph at the beginning of a research paper called?
Abstract.
Abstract, and it includes a summary of the entire paper, including the results and the ending. What do we call the ending?
Discussion.
Discussion, not
Conclusion.
conclusion. It's called a discussion. Good. What's the variable that is manipulated?
Independent.
Independent variable. What's the mnemonic? Parents get manipulated. Parents are independent. Good. What's the variable that is measured?
Dependent.
Dependent. What's the mnemonic?
Children get measured.
Kids get measured. Kids are dependent. Good. Okay. Who's the group that gets the special treatment?
Experimental.
Experimental group. Who's the group that does not? Control group. If it's a drug study, what do they get? Placebo. Good job. What do you call other variables that need to be controlled for?
Extraneous.
Extraneous variables, and if you don't control for them, they become
Confounding.
confounding. So consider the acid rain on plants example. What are some extraneous variables that I needed to control? The soil has to be the same,
Amount of sunlight.
the amount of water, the location. I can't have one group in the sun, right? If you have confounding variables, so again, extraneous variables that are not controlled for, can you say that it was the acid rain that hindered the growth of the plant? No, because we don't know. It could have been the soil. It could have been the fact that one group of plants were in the sun and the other weren't. So that's why we have to control for the extraneous variables. When we do all these things, what are we conducting? An experiment. And that's why experiments can give us what?
Cause and effect.
Cause and effect. Correlation can't because you're not controlling anything, right? So correlation, yeah, you can predict from it, but if there is in fact like a strong correlation, you could have predictability, but you can't have cause and effect. You can't determine cause and effect because the other extra variables, the extraneous variables, are not being controlled for. Understand? Okay. Yes. No, I still haven't done the rice experiment. I know I need to. Did anyone else do it? So third period, I think it was Isaac, right? Where'd you go? Where'd Isaac go? He was here. Okay.
He went.
So Isaac mentioned this experiment where it's like dried rice and you like yell at it.
Okay.
So you have one thing of rice and the other, and you yell at one, and the other, I think you talk nicely to, and the one you yell at like turns black or something. I don't know. It was something like something interesting. What? Not black, but it turns like
Pretty, I think
darker.
Yeah.
Or something.
It was something. I was like, huh?
Brown rice.
Actually, I want to do it.
What? Olive oil?
What
makes
Remember. Okay.
brown rice is so expensive?
Are they real? Are they humans?
All right, here we go.
No idea.
So, a physiologist sets out to determine, by the way, on the test, on the final and on the AP test, physiologist is different than psychologist. Physiological is different than psychological. Physiological refers to the body, psychological refers to the mind. Be careful when you read, okay? Because if you read quickly, you can make a mistake and think it's the other one, all right? So, a physiologist sets out to determine whether the caloric content of food, high calorie versus low calorie, is a determinant of the amount eaten by rats who have been subjected to 48 hours of food deprivation. What's the independent variable?
Calorie content.
The caloric content. What are the levels of the independent variable? High calorie and low calorie. What's the dependent variable?
The
Amount eaten.
The amount eaten by rats. Good. Okay. On the test, you can expect to get scenarios where you have to say what's the independent, what's the dependent. Operational definition, what is it?
It describes.
You have to be specific. So let's say it's operational definition of the independent variable for the sugar and hyperactivity. What might you say?
Oh, yeah.
Independent variable.
Oh, independent. How much?
The amount of sugar they eat, in what form, is every kid getting one, 2-ounce candy? That's probably a lot, right? So it's what kind of candy, what time of day, those are the specifics of how you set up the experiment. And then the operational definition of the dependent variable could be how you measure hyperactivity, so the amount of times they get out of their chair. Okay, remember that for your response I gave you guys?
Yeah, got that one.
Good. Confounding variable, once again, is an extraneous variable that is not controlled. Good. Remember the M&Ms?
Oh, yeah.
Okay. So that had to do with sample size, but first, random sampling. How do we randomly sample?
Put all names.
Put all the names of the
Population.
population in a hat, and without looking, you pick out however many you need. Okay? How do you randomly assign?
You flip a coin.
For each name, you flip a coin. If it's heads, it goes
To
to
experimental.
the experimental. If it's tails, it goes to the control. Okay, good. So when we randomly sample, we're ensuring that everyone
Gets equal
in the
chance.
population has an equal chance of being selected for the study. When we randomly assign, we're ensuring that every subject has an equal chance of being placed in the control or the experimental group. Is that clear? Okay. Sample size. So that's what's the deal with sample size?
Sample size has to be
The bigger the size, the better, right? Remember the M&Ms? How I gave you the little packs, and some of them didn't even have yellow ones, right, or brown ones. So was it a representative sample? No. So in order to have a representative sample, you need to have a bigger sample size. You can't do a study on 5 people and be like, oh, this means this. Because it's 5 people, like things could have easily just by chance gone wrong, or it's just not, it's not gonna give you an accurate measure. You need like 100 people or 1,000 people or, depending on what it is. Good. And by population, do I mean the whole world population? No, the group of people you are interested in. Good. Sampling bias, is that a good thing or a bad thing? Bad. Okay, bias is bad. So sampling bias, so for example, if you have a small sample size, that's going to give you bias. If I'm measuring study habits of Birmingham students and on average how many hours a week do they spend studying, and I only survey my AP Psych, is that going to be accurate? No, it's going to be bias. That's convenient sampling, right? Not randomizing. If I only pick the kids in the library, right? Random assignment, we did. Placebo effect, what does it mean?
When our expectations affect how you feel or behave.
Good, our expectations affect how we feel or behave, good. And yeah, that's pretty much it. So, okay, if you do a drug study and the control group who gets the placebo, let's say it's a anxiety-reducing drug. If the control group who gets the placebo reports a 20% reduction in anxiety, and the experimental group also reports a 20% reduction in anxiety, what is the reduction caused by? The placebo effect, because they both went down 20%. So even the group that didn't get an actual drug, but got the fake one with no medicine in it, if they went 20% down, then you know their placebo effect, so the other one has to be too. What if the control group went down 20%, but the experimental group went down 50%? The drug is 30% effective. Got it? What is the advantage of experiments?
Cause and effect.
You can draw cause and effect conclusions, okay? It is the only type of study that can give you cause and effect conclusions. Why? Because you control for the extraneous variables. Good. What are the disadvantages?
Artificial.
They're artificial because we know it's an experiment.
Ethical concerns.
If they're unethical, we can't do them. And sometimes if they're impractical, we can't do them either. So you want to see the effects of malnutrition on the IQ, of malnutrition during infancy on IQ. Can you starve a bunch of babies? No.
Why would you do that?
I know that's kind of a drastic example, but you remember it. So. All right, longitudinal versus cross-sectional studies. Show me with your hands longitudinal. Long, right? A study over a long period of time. Cross-sectional is a short study. Give me an example of a short study. Zimbardo would be cross-sectional, kind of. It's just a week. Ash for sure. Okay, Milgram for sure. What about longitudinal? Hazen and Shaper. Okay, comparing attachment styles in infancy to attachment styles in adulthood. What type of psych? What area of research would a lot of longitudinal studies be? Developmental. Okay. Naturalistic observation, what do we do?
You observe without interfering.
You observe without interfering. They shouldn't even know you're there, right? What's the advantage? Less artificial. What's the disadvantage?
Can't draw cause and effect.
No cause and effect. Good. Case study, what is it? In-depth study on one person. What's the advantage? It's very in-depth. What's the disadvantage?
No cause and effect.
You can't determine cause and effect, and
Can't generalize.
you can't generalize to the population because it's only
One person.
One person. Good. Surveys. What is it?
Questionnaire.
A questionnaire. You're asking for people's opinions. Good. What's the advantage? You can get a lot cheaply and easily. Okay, it's inexpensive. 3 disadvantages. Deception, which means people lie. Response set, which means people answer in a pattern without reading the question. And
Social desirability.
Social desirability bias, which means people answer
in a way that
the way they think people want them to answer. Good. And you can't determine cause and effect. Okay. Measures of central tendency. What are the 3?
Mean, median,
median, mode. Good. Mean, what do?
Take the average.
You add them all up and
Take the average.
divide by the number. How many pieces of data you have? What if one piece is 0? You still include it. You still count it when you figure out how many you have, right? So if it's like 1, 0, 3, you do 1 plus 0 plus 3 divided by 3 because there are 3 pieces of data. Good. So what's the mnemonic for mean?
It's mean that you're mean.
It's mean because it makes you do the most work. Good. What about median?
Middle.
You find the middle number. What if there's an even number of data? You take the 2 middle ones and you divide by 2. Basically, you find the average of the 2 middle ones. What do you have to do first before you do any of it?
Order the numbers.
You have to put them in order first, right? Otherwise, it's not going to come out accurately. What's the mnemonic? Small, medium, large. Medium sounds like median, and it's in the middle. Good. What about mode?
Momo.
Momo. The one that appears the
Most.
most. Can you have more than one mode?
Yeah.
You can, right? If you have like 3 1s and 3 5s and the rest are only 2 or 1 of each number, then yes, 1 and 5 would both be modes, right? Can you have more than one median?
No.
Nope. Can you have more than one mean? No. Okay, correlation. What does it mean? There's a link between 2 variables. So there's a relationship, right? So high scores on one may indicate either high or low scores on the other. Okay, show me with your thumbs positive. This or this. The point is the thumbs have to face
The same
the
direction.
same direction. Show me negative. Good. Okay, I'm going to give you an example. You're going to show me with your thumbs, okay? All right. Amount of donuts eaten and hyperactivity. Probably like this at first, right? And then you crash. Yes, so good. The more donuts you eat, the more hyper you are. The less donuts you eat, the less hyper you are. What kind of correlation is that?
Positive.
Positive, good. Let's see. Hours spent studying and your score on the final. Positive. Positive. The more hours you study, the higher your score on the final, right? The less hours you study, the lower your score on the final. Remember that. All right. What about what about hours? Let's see. Amount of sleep you got the night before, and alertness the next day.
Oh wait, no.
Amount of sleep you got the night before. The more sleep you got, the
Sleep, the
higher your alertness.
Yeah.
So it's actually positive. It's positive.
I like
Okay.
the attendance.
What about, let's see, absences and GPA? The more absences, the lower your GPA in general, usually, okay? Good. All right, what's a perfect correlation?
It equals 1.
It equals 1 or
Negative.
negative 1. What's this kind of perfect correlation? Plus 1.
Plus 1.
What's this kind? Negative 1. What's this kind? Plus 1. What's this?
Negative 1.
Good. Okay, what would it look like on a graph? All the dots are on a straight line, okay? And we would say that that gives you perfect what?
Predictability.
Predictability. Good. Perfect predictability. Okay. All right. If you have dots all scattered, what is that?
No correlation.
No correlation. Okay? So scatter plot, even if the dots are all on the line, it's still a scatter plot. Okay? So but if the dots are, if they don't form a clear like tendency, either positive or negative, then we say it has no correlation or 0 correlation. What's the coefficient? What's the number? 0. Okay? What if they're kind of like almost on a line, but not quite? Strong, this way would be strong positive, this way would be strong negative. What if they're kind of loosely around the line? Weak positive or weak negative. Good. So the closer they are to the line, the stronger the correlation, which means you have greater predictability. Are we good on correlation? This also, you'll have examples and you'll need to say if they're positive or just like, honestly, go over your old tests. That's a good study method too. Just go over all that. It'll refresh your memory. And I'm going to repeat some of those questions. Hint, hint. Okay. Which is the strongest correlation? A, 0.9. B, 1.18. C, negative 0.95.
Negative 0.9.
Negative 0.95. So even though it's negative, it's still closer to negative 1 than 0.9 is to 1. So it would be considered stronger. Statistically significant. Turn to your partner, tell them what it means.
Probability that your results are due to chance is less than 5%. So basically, P is less than or equal to 0.05.
Point zero. Yeah, 0.05.
You need to remember this number. Remember, so never take it
never
become
did,
skinny.
though. Should we never had that on the test?
Did you have it? Oh no, I just when you had it. What was that? Oh.
Oh yeah, I remember.
Yeah, I remember.
Yeah, we did that. That was on the test.
I remember
right?
this number by heart.
We had to say
Like the
it was
question.
like 0.
Yeah.
And it means that it was probably due to chance.
And then it was on the figure stuff.
If it's more than that, then they're like, not today. Ooh, drawing.
All right, so statistical significance means that the likelihood that, like, you do an experiment, right? Or you do a study, and guys, and you get the results, and if there's something in it that you don't have to figure this out for AP Psych, but when you take like stats in college, you'll probably have to figure it out. But now they have computer programs that you just put in the data and it gives you the statistical significance. So if it turns out that your results seem like they're due to chance, it's not good. So you want that likelihood that they're due to chance to be lower than 5%. So in a decimal, equal to or lower than 5%. So in a decimal, that's less than or equal to 0.05. That means 5%, right? So P stands for probability. Statistical significance means that the likelihood that the results were due to chance is low. P is less than or equal to 0.05 or 5%. Cool?
Mm-hmm.
Okay, and you do need to memorize that number. Yes. No, because you'd need it would require like a bunch of data numbers and then a formula. So the only thing they would give you on the test, they might say, which of the following p-values implies statistical significance, and as long as the number is less than 0.05, you're good. Or on the free response, I've already seen it a few times, where they'll just say, explain what it means that this study is statistically significant, and you would just say, this study is statistically significant because the likelihood that the results are due to chance is less than 0.05. Or the probability that the results are due to chance is less than 0.05. Yeah?
If they gave negative numbers, it's the same thing, right?
It wouldn't be negative. The probability can be negative. Right. Yeah, yeah. So if it's like 0.0001, that's great.
The more zeros, the better.
The more zeros, the better. Yeah. Okay?
AP
All right.
stats.
Point.
App stats.
Validity and reliability. What's the mnemonic for validity? Check. I did everything I was supposed to. I controlled for extraneous variables. I randomly sampled. I randomly assigned. I had a big sample size. Okay? So if you do all those things, then the experiment is valid. It's legit, right? If you don't do it, is your experiment valid? No. So you want to have high validity. If you have low validity, your experiment's kind of worthless. Understand? I mean, really, right? Like you go through a whole experiment, but if you only did it on 5 people, right? Or you go through a whole experiment, but then you forgot to control even one extraneous variable, do you know if it's the independent variable affecting the dependent variable? No. So you have to do all that stuff, so it's valid. Reliability starts with R. What else starts with R?
Replicate.
Repeat.
Results.
Replicate. So if you repeat the experiment and you get the same or similar results, you have high reliability. If you repeat it and you get totally different results, you have low reliability. So what do we want? High reliability and high validity. Clear? Good. The range. So you have a data set, you take the highest number minus the lowest number. So you subtract, so listen to the math language. You subtract the lowest number from the highest number. You subtract 2 from 10. You understand? Mm-hmm. And that's the range. That's it. That's easy. Variability, again, if you have a high range, you have high variability and you have high standard deviation. If you have a low range, you have low standard deviation and low variability. Okay? So the red, you can see, goes from 10 to 90. So what's the range? 80 80. Good. The blue goes from 30 to 70. So what's the range? 40. So which has the higher range? The red one, right? And which has the higher variability? The red one. Which has the higher standard deviation? The red one. Which has the lower range? Which has the lower standard deviation? Which has the lower variability? Blue. They're all correlated. So if they give you data, like, 5 sets of data, A, B, C, D, E, and they say which one has the highest standard deviation, what are you going to find? The range. Because are you really going to find standard deviation for 5 data sets on a multiple choice? No. So just find the range. It's super easy. And remember, highest number minus lowest number. Pay attention that the numbers are in order. Okay? Because if they're out of order, don't just take the end one. You get what I'm saying? Okay. All right, good. Standard deviation. What's a mnemonic?
Mean dog, slaughter, mean rats.
Mean dog, slaughter, mean rats. Mean. What's the first thing?
Find the
mean of the whole data set. Dogs. What does D stand for? Find the difference. So if the mean is 5, or I think in this case it was 4, minus 4, minus 4, minus 4, minus 4, right? Okay, difference. Mean dog, slaughter. What's the S?
Square.
Square. Square each one. Okay? Mean dog, slaughter, mean. Find the mean of what you have now. Okay? And what did you just find? Variance, right? And then what do you do to it?
You square root it.
Rats is root. So you square root it, and that gives you the
Standard
deviation. Tell your neighbor how to do it again. Go.
So you find the mean of the first data set, and then the difference is subtract by the mean you got, and then square, you have to square the new one, and then from there, find the mean again of the data set, and then add everything and you do it, right?
Well, no, yeah.
Kind of. She's there.
Find the mean, then you square root it. Bam. There you go. Standard deviation.
Mean dog, slaughter.
Math is amazing.
That's why I
That's what I do. I should
Variance.
No, it does not. Nope. So the question was for standard deviation, do you have to put the numbers in order? You don't. You don't. Okay, good? Okay. Normal distribution, the rule, remember this thing?
That confuses me.
60,
68, 95,
99.7. 99.7. Okay, everybody. It really helps if you have a movement attached to it. 68, 95, 99.7. One more time.
68, 95,
99.7. What percentage of people fall within one standard deviation of the mean?
68%.
What percentage of people fall within 2?
95.
And what percentage fall within 3?
99.7.
And that's for a normal distribution, for a bell curve. Okay? I'm not going to go over that one question with the craziness.
This one.
Yeah, I'll do that before the AP test.
It's
That one.
Okay, skewed distribution. What's pulling the mean?
The outlier.
The outlier. The outlier, and yes, the mean is pulled to the tail of the whale, meaning toward the outlier. So here's Bill Gates' salary, way above everybody else at Microsoft, right? So the mean usually would be around the mode, right, if it were like a normal curve, and then Bill Gates' salary is pulling the mean
Down.
toward it, right? Toward the tail of the whale. So that's a positively skewed distribution, right? Because it's skewed in a positive direction. Let's say there's something, let's say test scores, like most students scored around 70, and then one student accidentally used pen on their Scantron and got a 0. What would the 0 do to the mean? It would pull it toward the left, and that's a negatively skewed distribution. Understand? Okay, good. We really have to move fast. Okay. Researcher bias, also known as experimenter bias. Why does it happen?
Because the researchers...
So the researcher either, probably not on purpose, because, we assume Yeah, they just kind of like influence because they project their opinions on people, and so they might unintentionally influence the subject. So to avoid this, what do?
Double
The
blind.
double-blind procedure. We hire someone else to do the research or to do the experiment, and do we tell them the purpose of the study?
No.
No. Do we tell the subjects?
No.
No. So double-blind. Neither the subjects nor the experimenter know the true purpose of the study. Double-blind procedure. What would single-blind be? Just the subjects don't know. And sometimes that's fine, you know? It kind of depends on the study you're doing. But double-blind procedure eliminates researcher or experimenter bias. Okay, ethics. So what do you call the fact that people can't just be forced into an experiment? They have to volunteer.
Informed consent.
Informed
Consent.
consent. They have to give consent, right? What about after the experiment is over, you can't publish the names? And anonymity, rights to privacy. Good. You cannot publish the names and scores. Remember that free response I gave you guys?
Yeah.
Good. Okay, what about after they leave, before they leave the office, you must tell them the true purpose? Debriefing. Can you wait till they get home?
No.
It must be before they leave
the
the office or lab or wherever you did the experiment or study. Good. Is harming animals okay?
Yes. Only if it's benefit.
All for the benefit.
Technically, it's okay if the benefits outweigh the kind of like risks, I guess. Yeah. Again, that's very subjective, but yes, you can harm animals in science. I mean, you know. Okay. Nothing harmful or dangerous to humans. Moderate mental discomfort is okay. Which study kind of violated that? The Zimbardo study, and Milgram is questionable. Okay, but I don't know if that was a rule before. I don't know if the rules were exactly the same at the time. I don't think they were.
Yeah. You can't. It's subjective. You can't measure it, really. I mean, you could give them like a psychological evaluation, but still, it's still going to be, there's no like, oh, they're under, they're over, you know? It's subjective.
Okay, and the study must be pre-approved by the university. Pre-approved. Okay, while I set up chapter 3, I want you to do chapter 2, heads up. Go.
Do we have to know the quasi-experiment or?
Oh, yeah.
When all of it
Thank you.
Yeah.
Quasi-experiment, one more. So that's when you do an experiment, except you don't
Randomly
assign, because you can't, because they're already like in the groups naturally. Okay? All right, good. Heads up.
So it's like mandatory.